Our class, this is day one of key features of graphs, and we're going to look at three graphs here: the parabola, linear, and exponential. Okay, so let's look at the parabola. A key thing to remember are the x-intercepts. That's where the line crosses the x-axis, and the y-intercept is where the line crosses the y-axis. All right. The axis of symmetry is the line that splits the graph in half and crosses the x-axis. It also goes through the vertex, the axis of symmetry. And the axis of symmetry is an equation. A lot of students write it as a point. It is an equation, so make sure you put x equals wherever the line crosses the x-axis. And the vertex is that point in the graph where the graph changes direction. So if you are traveling along this graph right here, at this point, the graph stops going down and starts going up. So that's why it is called the vertex, okay? And in this case, it is a minimum. Um, if the graph opens downward, right, then the vertex would be on top and you have a maximum. So those are key things to remember about that. Also, one thing I want to show you, if you can see this, in this case, the axis of symmetry is x equals 1. The vertex, right? The vertex is 1, -4. 1, comma, -4. And so if you notice, right, the axis of symmetry, the value of it is the same as the x coordinate of the vertex. All right, guys. Okay, let's look at the linear graph. Same thing that the y-intercept is where the line crosses the y-axis, and the x-intercept is where the line crosses the x-axis. Did I say that correctly? The y-intercept is where the line crosses the y-axis, and the x-intercept is where the line crosses the x-axis. Okay. And then the slope in this case is rise over run. And so to find the slope, I would go up 1, 2, 3, 4. So that would be my rise, 4, and my run is 1, 2, 3, 4, 5. Now the way I like to explain rise over run is right. If I go up and to the right, my slope is going to be positive. If I go up for my rise and then left for my run, then my slope is going to be negative. So that's one of the tricks you can use to make sure you have the right sign for your slope. Now let's look at exponential. In this case, let me make sure I write this down. We're going to talk about this in a second. F of x is equal to a to the x, and f of x is equal to b times a to the x. All right? I'm going to come back to this in a second. Now, when we talk about exponential, right, if there are no restrictions, on a graph, right, your domain is going to be all real numbers. I want to stress that. Your domain is going to be all real numbers. And your range is going to be y is greater than 0. Okay, that's 2. And then your horizontal asymptote is going to be the x-axis, which is y equals 0. I want to stress that. All right. And also, there are no x-intercepts because the line does not cross the x-axis. All right, guys. So make sure you get those key points down. Now, in this case, in the graphs here, as x increases on the left graph right here, as x increases, right? If you notice, the graph decreases. The graph decreases, right? And that's for when the a value is between 0 and 1, when a is a fraction, all right? When a is a fraction. So when a is between 0 and 1, let me put it like this, all right? All right, the graph decreases. On the other side, when a is greater than 1, right, the graph increases. So as a increases, the graph goes up. Okay, so that's this bullet right here. Now let's talk about y-intercept. All right. Now in this graph right here that's shown in the example, right? The equation is of this format. All right. And so let me put some numbers against this. Sometimes it clarifies things. So let's see. The first one, let's see. Let's make this f of x is equal to, let's go with 2 to the power of x, right? And for the second equation, let's go with f of x is equal to, let's go with 3 times 2 to the power of x. Now here I have y, I have here the y-intercept is 1, right? That is for the first equation, because when x is 0, anything raised to the power of 0 is 1. So that's why we have y equals 1 for the first equation. Now, if the initial value, right, is anything other than 1, here it is 3, right? Then 3 is going to be your y-intercept because, again, when x is 0, this expression becomes 1. And so you have y is 3. Just want to make sure you see the difference in those two equations, all right? Okay, I think that's all for exponential now. So let's move on to our first example. Here you have a parabola. It faces down, and it wants to know what is the maximum value of the graph. So the maximum value is going to occur right about here. So let's see what that point is. What's the unit for that is? 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. So that is 9. So the maximum value for that graph is 9. So you make sure you bubble in the plus sign, and then you can bubble in 9. Okay, I like to go. A lot of teachers do it differently. Some like to bubble it at the in the last grid bullet right here. But as long as you're consistent, just make sure you have a positive and you have 9 there. Next one is you're given a function shown on the grid, and what are the zeros? So remember, zeros, right? It's one thing I want to stress. Zeros, x-intercepts, solution, all right? They are the same thing we're looking for. Same thing, all right? We use it interchangeably. So in this case, let's see what our zeros are. Now, if you notice the graph crosses the x-axis between the integers. So we know there are two solutions, two zeros, right? Because the graph crosses the x-axis here and here. So there are two. So A is not an option, and C is not an option. Let's look at B. One of the zeros is 9. That is not going to be an option because 9 is way up here on the graph. All right. So your option is the correct option is D. All right. 1/3 and 3/2, and 3/2 is 1.5. You can see 1.5 is between 1 and 2. All right. Let's see what we have next. Here, what is the y-intercept? Remember, the y-intercept is where the line crosses the y-axis, and so that is 1, 2, 3, 4. So 4 is your y-intercept again. Make sure you bubble the positive sign and you put in 4. All right, as your y-intercept. And here you're given a quadratic function, parabola, and it asks you what is the axis of symmetry. All right, remember the axis of symmetry is a line that splits the graph in half, and that line crosses the x-axis at 2. So that's going to be x equals 2 is your axis of symmetry. So that is G. Okay, this example asks you which dashed line is the asymptote for the graph. And here it does, let's see which it's an asymptote. Line R and S. Okay, this is an example where I talked about where the The horizontal asymptote is the x-axis, right? Is the x-axis, and sometimes, which is y equals 0. Here it is s. So line S is your horizontal asymptote. The reason I paused for a second is they didn't stipulate. I would love for them to say horizontal asymptote. They did not do that. Okay. So line S is the asymptote. Now, 49 asks you which statement about the graph is true. Okay, the graph has a vertical asymptote. Okay, the graph crosses the y-axis at 0,29. No, that is not true. Right, the graph does not cross the y-axis at that point. It crosses the x-axis at 1. It crosses the y-axis at 1, 2, 3, 4. Looks like 5 there. So that's definitely not correct. The graph has an asymptote at y equals 1/3. Again, that is not correct. The asymptote is at y equals 0, which in this case is s. So that's not correct. The graph decreases from left to right. The graph decreases from left to right. Well, not really. If I go from left to right, the graph is increasing. So that's not correct. And so your correct option is A, right? It has a vertical asymptote. In this case, it is R. Okay. And that's why I wished in this question they had clarified which asymptote they're looking for. All right. Good. Let's move on to the next one. Which statement about the graph of y equals 8 times 0.25 raised to the power of x is true? Which statement is true? Let's look at F, the coordinates of the x-intercept. Remember, there are no x-intercept when it comes to exponential function, right? Because the graph doesn't cross the x-axis, so we know that it's not correct. The coordinates of the y-intercept is 0,8. Well, let's see. Remember when the y-intercept occurs when x is 0. In this case, let me write this. Y is equal to 8, 0.25x. So when x is 0, this expression is 1. And so, yes, y is 8. Okay, so that looks good. Let's look at the other one. The equation of the asymptote is x equals 0. No, the equation of the asymptote occurs at y equals 0. So that's not correct. And the graph includes a point. No, if you plug in these points, right, that is not correct. So there you go. So your answer is B. All right. Let's move on to this one. Okay, let's see. The graph best represents. Now on this one, which graph best represents the function? We can do two ways. We can graph it, or we can work it out. So the function is f of x is equal to 2 times f raised to the power of x. All right. And so by looking at where the line crosses the y-axis, right, we can eliminate h and j. Why is that? When for the y-intercept, right, that occurs when x equals 0. So when x is 0, this becomes 1 because remember anything raised to the power of 0 is 1. And so the y-intercept is 2. In this case, we can take out j and we can take out h. So that leaves now f and g. Now what I'm going to do now is, and this is what I want you guys should be able to do, look at a graph and try, do some analysis and see which one is the best answer, all right? Now let's look at when, I'm going to look at this hash mark right here. It's a good one because the line crosses the hash mark. I'm talking about G, right? When X is 1, right, the Y value is 5. All right, so let's see what's the Y value when X is 1. Now, when X is 1, I'm going to get, let's get some space. I'm going to get f of x, right? when f of 1. Okay, when x is 1, right? That's going to give me 2 times 5 raised to the power of 1. Well, 5 to the power of 1 is just 5. So that gives me 2 times 5, and that equals 10. Over, this is 5. So when x is 1, that's 5 right there. So G is not the answer. When x is 1, right, the y value is 10. So F is the answer. All right. So that's how you can do some reasoning and figure out which one is the correct answer. And we can graph it. All right. If we graph it, right, it's going to look like this. And that, again, you can see that is similar to, if I go scroll up, that looks like I graph F than H. I'm sorry, than G, right? That's more in line with F than G, all right? So that, again, that's another way you can figure out how to solve these exponential graphs. Now, on this one, we're talking about exponential growth. All right, and so the formula for that is uh, f of x. F of x is equal to a times 1 plus r to the power of x, right? Where r is the growth rate, right? A is the initial value, and the 1 plus r is your growth factor. Now, if this was a decay, right, then my equation would be f of x is equal to a times 1 minus r to the power of x. And how do we know that this is a growth? Well, it says that, let me erase this. It says that the company awards an annual increase. So that's my cue that I'm going to use the 1 plus r to the power of x. So all we got to do now is my rate is 6.2%. I need to convert that to a decimal and then add it to 1. All right. And so 6.2% is, as a in decimal, is 0.062. Okay, if you're not sure to do that, just divide 6.2 by 100, and that's how you get the decimal right there. And so let's write the equation now. I need some space. So f of x now, my equation is going to equal to my initial value is 29,000, right? That's my initial value. And I'm going to need more space. Let me try to find some more space to put this one here, guys. Let's see. Where can I? I don't want to space at the bottom. Nope. Okay, let me extend my page a little bit and see if that will work. Let's go with that right there. All right. So f of x now is going to equal to my initial value a, right, is 29,000 times 1 plus my rate now in decimal, right, is 0.062. That raised to the power of x. And so that's going to give me 29,000 times 1.062 to the power of x. So we got to figure out now. Now to graph this, if you the numbers are, this number is too big to graph for you to see it on the graph clearly. So we're gonna have to use some reasoning and elimination to figure out which one is the correct answer. Well, let's look at the y-intercept. All right, the y-intercept occurs when x is 0. So when x is 0, right? When x is 0, this becomes 1. Because remember, anything raised to the power of 0 is 1. Therefore, my y-intercept is 29,000. Therefore, I can eliminate D and C because the y-intercept is around 5,000 or right about 5,000, and also this one right about 5,000. So I can eliminate C and D. So that leaves A and H. So which one am I going to pick for those two answers? Now, if you look at it, B, the graph is increasing at a very fast rate. Therefore, my growth factor would have to be a very big number to increase at that rate. All right. Right now, my growth factor is just 1.062. It's not. That's not a very that's not going to give me a very fast growth right there. So I'm going to say A is my answer because it increases at a slower rate than B. All right. Now on this one, this is a pretty easy one. Which graph shows a line with an x-intercept of -5? So that's going to be of -5. That's not this one. -5, no. No. So the answer here, -5, x-intercept of -5 is this one. That's A right there. All right. On this one, there are a couple ways, several ways you can do this one. You can graph it. You can put the equation in slope intercept form, or you can find the x and y intercept from the standard form right there. So let's put this in slope intercept form, and so we can see the y intercept. All right, and the slope. So here we go. What I'm going to do. Let me get some more space here. Extend my page just a little bit so we get some more space to work with. So um, the equation is -3x. Let me go with black. The equation is -3x plus 5y, and that is equal to -15. Now I want to put it into slope intercept form, which is, remember, y is equal to mx plus b. All right. So I want everything on the right side except my y value, except my y. So what I'm going to do here is I'm going to add a plus 3x and a plus 3x. Okay. That goes away. So I'm left with 5y is equal to 3x minus 15. And now I want y, just y. So I'm going to divide both sides by 5. And that's going to give me, divide by 5 here, divide by 5, divide by 5. And that gives me y is equal to 3/5 x, right? Minus 3. So my y-intercept is -3 and my slope is positive. So let's see which one gives me that. Well, we know my y-intercept is -3. So that's not going to be running, and this is not in the running. So that leaves me A and B. Y-intercept, y-intercept. Which graph to go with? Well, my slope is positive. I have a positive slope, and so this B, right, has a positive slope. So I'm gonna go with B. So B is my answer. All right. So that's one way of doing it. Another way I could have found the x and y intercept from the standard form of the equation. And if you remember, uh, this is my A, that's my B, and that's my C. To find x-intercept, right, is C over A, and my y-intercept is C over B. All right, C over A is just going to be, let me get some more space down here, guys. C for my x-intercept, right? C over A is going to be -15 divided by -3, and that is 5. And my y-intercept we just found too is going to be C over B, which is -15. Oops. -15 divided by B is 5, which is -3. So which graph has an x-intercept of 5 and y-intercept of -3? Again, B. So another way you could have done it, and then you could just graph it. All right. Okay, so that's 23. Now on this one, I have to admit I had to read it like 3 times to figure exactly what they're saying. I think the wording could have been worked on just a bit more. So here we go. A lifeguard earns 320 per week for working 40 hours. So that's a key part right here. So he earns 320 per week for working 40 hours. That's one key statement right there. Okay, let me put up up here right there. Then once he hit 40 hours, then his pay increases. He starts making $12 per hour, right? Then he start making $12 per hour. So you got to think now. He's working, and he makes once he hits 40 hours, he's making 320 right there, and then at that point, he start making more money at $12 per hour. So our equation now is going to be this, all right? Our equation is going to be y is equal to the rate, all right, at $12 per hour is 12x, and the initial value, the initial starting point for when he start making this rate right here, the initial starting point is going to be 320 because that's how much money he has made so far. And so the question asked is a question now: which graph best represents the lifeguard's weekly earning? Right, once he hits 40 hours per week. So let's look at the graphs now. Now the initial value when x the initial value when he hit 40 hours, right, is 320. As you can see, I can eliminate H and J because it's at zero right there. Okay. And so now we're back to we have two choices now, F and G. So which one is going to be our answer? Well, let's see. Let's look at, I look at, and I wish I had my calculator too. Let's look at the graph F, right? When when x is 10, right? When x is 10, right? He's made $400 right there. So let's put that in a graph and see if that is correct. So when x is 10, I'm going to need a little more space. Okay, let's do it right here. So when x is 10, right, I'm going to say y is going to equal to 12 times 10 plus 320. So that's 120. So that's going to be 120 plus 320. And what is that equal to? That's 0, that's 4, that's 440. All right. So that is not, so it can't be F because at 10 hours, according to this graph, he's made $400. Well, according to the equation, it should be 440. On this graph here, when X is 10, it's above 400. So G is the correct answer. So that one, yes, that one took me a little while to figure out what they were saying. On this one, you're given a graph and you're asked to find which order pair best represent the location of the y-intercept. Again, the y-intercept here and the graph is not of good quality, but it looks like it is -1, 2, 3, negative. Let's see. -1, 2. It looks like it's going to be, so the y-intercept is at 0, comma, -2, and which one is that going to be? G. All right, negative y-intercept. Okay, and the other one is you're given a graph, and what is the 0 of G? Remember, 0 is the x-intercept, right? And that's going to be at -1, 2, 3, 4, 5, 6. That's 6. Let me -1, 2, 3, 4, 5, 6. Yes. So that is -6 is the x intercept, and so again for the griddable, you bubble in a negative, and then you go down to 6. All right, 5, 6, right there, -6. All right. And let's see what's the next one going to be. Here you're given a graph and you're asked to find which statement best describes the y-intercept of the graph. Again, let's see. The y-intercept, if the water level increases, no, they're not asking about increase. They want to know the y-intercept. That's not F. The maximum water level was 19.5 feet. No, the y-intercept is at 16, so that's not gonna. The water level, yes, the initial water level was 16 feet, right? So that is um, the y-intercept. All right, let's see what's next. Okay, did I miss one on here? Ah, I missed one on here. 27. Um, a paper plane was thrown from a tall building, and the function y equals negative 1.5x plus 60 models the path of the plane and wants to know where it's wants to know how many seconds did it take the paper plane. Okay, how many seconds? Okay, so let's if you can sometimes if you visualize this, it kind of helps, right? So here it says that uh, the plane was thrown from the top of a tall building. All right, so this is the top of the building right here, and it was thrown. And so this is a linear graph. So it's going to come straight down like this. All right, again, come straight down. All right, and so bottom line, you need to find x, right? Because you want to know when the plane hits the ground, right? The height is now 0. All right, so I got to find x now. I'm going to set y equals 0 because again, when the plane hits the ground, right, the height is now 0. I have to find x. And so let's solve for that. So we're going to have 0 is equal to negative 1.5x plus 60. Okay, and so I'm going to move this negative 1.5x onto this side of the equation. Therefore, I'm going to add plus 1.5x and 1.5x. Oops. Okay, that goes away. So I'm left with 1.5x is equal to 60. And so to find x now, I got to divide 60. I got to divide 60 by 1.5. And that's going to say 60 divided by 1.5, and if you use a calculator, that's going to give you 40. So x is equal to 40 seconds. All right, and so all you got to do now is go to your gradable. We know it's going to be a plus 40 seconds, so 4 and 0. All right. Okay, are there any more questions on this one? Yes, we have another one. Here you're asked to find which line appears to have an x-intercept. Again, it's a pretty easy one of -5 and a y-intercept of 3, right? -5, and you can look at it. This one, -5 is here. No, that's not -5. My highs are bad. 1, 2, 3, 4, 5. So this -5 and +3. G is the answer. All right. And then the next question is, what is a y-intercept of this graph? Again, the y-intercept is where the line crosses the y-axis. That's 1, 2, 3, 4, 5. 5 is look like it's between 5 and 6. Now, when on these tests, right, STAAR tests, when there's a line, when a line crosses between two numbers, two integers, right, it's safe to say it's 5.5, and we can prove that. Again, I'm going to set 5.5 because it splits between 5 and 6. 1, 2, 3, 4, 5, and 6. And we can do that by finding the slope and find the y-intercept, right? Let's do that. Just let's prove that for a second. M is going to equal to my slope, y2 minus y1. That's going to be 1 minus 7 over x2 minus x1. That's 6 minus 2, 6 minus minus 2. All right. That's going to give me -6 over 8. 1 minus 7, that's 8. And that is going to give me -3 over 4. All right. So that's my slope. So I'm given 2 points. I'm going to use the point slope. I'm going to use the point slope method. So y minus y1 is equal to m times x minus x1. Y minus my y1. Let's go with this one. My y1 is 1, so y minus 1 is equal to negative 3 over 4 times x minus my x1 is 6. Okay, so what I'm going to do is I'm going to simplify this a little bit. So it's going to give me y minus y1 is equal to negative 3 over 4x, and then times negative 3 over 4, follow me, times negative 6, all right? So this is a minus right here. So that's equal to negative 3 over 4x. A negative 3 times a negative 6 is a positive 18 over 4. Everybody see that, right? I multiply negative 3 times 6 as a positive 18 over 4. You can make sure they make a mistake. Yes. And that is y minus 1. Okay. And so let's simplify. I'm going to add 1. In fact, I can stop here right now. Now, the y-intercept occurs. The y-intercept occurs when x is 0, right? When x is 0. So when x is 0, this is 0. When x is 0, this entire thing becomes 0 because 0 times negative 3 over 4 is 0. So I'm left with y minus 1 is equal to 0 plus 18 over 4. And that's going to give me y minus 1 is equal to 18 over 4, right? What is 18 over 4? Okay, let's simplify that for a second. That's going to be 9 over 2. 9 over 2 y minus 1. Everybody see that? All right, 18 over 4 is 9 over 2. And then I'm going to plus 1 on both sides. Plus 1 here, plus 1 there. That goes away. Y is equal to 9 over 2 plus 1. 9 over 2, if you do the math, right, is 4.5. 4.5 plus 1 is 5.5. All right. So I just proved that is 5.5. So circle the bubble in the plus sign. Oops, I'm ready to go. And then go to 5. Then I think this is the decimal point, and then 5 again. All right, another way of doing it. All right, guys. So remember, if a line goes through evenly between two integers on the axis, you can assume that it's a fraction, a 0.5. All right. Okay. What's next? Okay. Oops. Did I go back? What did I do here? Uh, Okay, I think that's the end of it, guys. Yeah, that was the last. All right, that was a very long review. Hopefully this helps you guys. All right.